Sorry, I don't have a teacher.
Okay, so today we're going to be starting our lesson on Newton's first law. Isaac Newton created a series of laws, the 3 laws of motion, that are really important in helping to solve different kinds of physics problems. And so as we're learning how to do more and more complicated problems, we want to have a really strong foundation in Newton's first law. So we're going to go over our objectives for the day. Our first objective is that students will be able to state Newton's first law. Second objective, students will be able to use a thought experiment to explain why Newton's first law of motion is true. Now we're going to practice our scientific vocabulary by reading our objectives out loud together. So number 1, I will be able to state Newton's first law. Awesome. Number 2, I will be able to use a thought experiment to explain why Newton's first law of motion is true. Nice. Okay, so before we get into Newton's first law, one thing that's really important in science is giving credit where credit is due. And so even though Isaac Newton was the scientist who ultimately published the 3 laws of motion, the first law of motion was actually first created about 600 years earlier by a Muslim scientist named Ibn al-Hasan, who was born in about 1000 AD, and he was a really prolific scientist. So he was doing work in optics, so how we see things, and physics, and geometry. He also created the scientific method that we still use today. Something that's really interesting that he kind of developed the idea behind was he realized that some objects, like the sun, emit light, and that all the rest of the objects reflect the light that object emits. So before that, people thought that the way that we see things was our eyes were emitting particles that would bounce off objects in our world and then come back to the eye. And he realized that basically the sun was illuminating our world and that light was bouncing off objects and then coming to our eye. So really important in optics and physics. And he developed the idea of inertia. So inertia is essentially how stubborn an object is. So objects resist change to their motion. If an object's at rest, it wants to stay at rest. So like when you're in bed in the morning, like you don't want to get up, you're stubborn, you want to stay there, you have a lot of inertia in that moment. And once an object is moving, it wants to stay moving. So like in cartoons, when you see the boulder rolling down the hill, the reason you don't want to just stand there and try to stop it, it has a lot of inertia, and so it wants to keep rolling right on through. So to check how well we understand the idea of inertia, we're going to do a couple questions here. So which has more inertia, an elephant or a mouse? Show me with your fingers if you think if it's an elephant, number 1, and if it's a mouse, number 2. Number 1, awesome. Julia, how come?
Because it's bigger and slower?
Yeah, it's bigger and it's harder to move, right? It's like if you go and push an elephant, probably not going to get very far, but if you go push a mouse, it's going to move. Nice. One more. Which has more inertia? 1, a rock, or 2, a loaf of bread? Nice. 1, a rock. Great. So it seems like you guys really understand inertia. Okay, so Newton's first law is essentially the idea of inertia. It's that objects at rest remain at rest, and objects in motion remain in motion unless they're acted on by an external force. So let's practice reading that together as a class. Objects at rest remain at rest, and objects in motion remain in motion unless they are acted on by an external force. Nice. Okay, so now let's think of some examples from real life. If I put this water bottle on the table, do we ever expect it to jump up and move away?
Mm-mm.
Yeah, probably not, right? We don't really see that happening. We're going to do a think, write, pair, share now. Thinking about these 2 questions. Have you ever seen an object that was not moving start to move? And can you identify an external force acting on this object that might have made that happen? So an example of this is if you're standing at the top of a ski slope on your skis and you're not moving, you might not have to do anything and you might start moving down the hill. And the thing that's making you move in that case is gravity. Okay. And then our second set of questions to think about are, can you think of examples of objects that never stop moving? Do these objects have external forces acting on them to keep them moving? So an example of this is a clock. The hands will keep moving around the clock, but they're being powered usually by a battery. And so that the battery is creating an external force. Okay, so we're going to take a minute. I want you to think about it and write down some ideas, and then you're going to turn to your partner and you're going to share with each other. Okay.
Object that was on start. I can't think of anything.
Well, we can be partners now.
Okay.
Yeah. Okay, so you had an example earlier. A car.
Oh yeah.
Yeah, so like if you get in a car
Mm-hmm.
and don't do anything but turn it on,
Mm-hmm.
what's going to happen?
It just sits there.
What if it's in drive?
Oh, then it'll start going forward.
Yeah.
Okay.
So that's an example.
Oh, okay, gotcha. Okay. Oh, so yeah, okay, yeah. So it has an engine to make it act. Okay. I've seen my brother start moving when my mom yells at him. Does that count?
I would also classify that as an external force.
Excellent. Okay. All right. Objects that never stop moving. My brother's not. Objects that never stop moving. Waves. Waves never stop moving. Like at the ocean.
Yes and no, right? Because as a wave comes into the beach, it's going to hit the beach,
Mm-hmm.
and that wave is over, right? So that doesn't last forever.
Oh, okay. I can't think of anything.
So, you guys had some really good answers to the first question. I was walking around and listening, and it seemed like you all had some really good ideas for that. So could somebody share an example that they talked about with their partner?
My brother's mouth? No. An object that was not moving. We talked about a car that it's not moving when we get in it, but then we turn it on and we put it in drive and put the gas on and it starts moving.
Mm-hmm.
So the engine would be the external force.
Nice, awesome. So that's an object that wasn't moving, and then it starts to move, but we can identify why, and it's because there's a motor that's making it go.
Mm-hmm.
Nice. Okay, how about this second question? This one was probably a lot more challenging. Did anybody have any ideas for that?
Do you want to tell me?
If you had one, if not.
The only thing we could think of was a wave, because the ocean's always moving.
Yeah, so the ocean is always moving, but it's always moving in different ways. So like when a wave comes into the beach and it hits the shore, then that wave is over. Yeah, so this one's a lot harder to think about, right? We don't really have examples of objects on Earth that stay in motion forever and don't have an external force that's driving it.
Mm-hmm.
And the reason for that is like, if you slide a puck across ice, that puck will keep moving for a pretty long distance, but eventually it will slow down and stop, and that's because of friction. So in our world, friction and air resistance slow down pretty much everything.
Okay.
If we look at Newton's first law again, objects at rest remain at rest. We have plenty of examples of that happening in the real world.
Mm-hmm.
Your notebook is staying on the desk right where you put it. It's not going anywhere. But we don't have very many examples, if any at all, for the second part of Newton's first law, which is that objects in motion remain in motion unless they're acted on by an external force. So the question is, if we can't really observe examples of the second part of Newton's first law, why should we think that it's true? And to do that, we're going to do an experiment.